Most parents drop a few $100s on a Lego robotics kit, expecting their kid to build career-relevant programming skills, only to watch them outgrow the platform in 18 months with nothing to show for it but a dusty robot collecting cobwebs in the closet. That's not a learning investment, that's expensive entertainment with a STEM sticker on the box. I'm Rajiv Patel, and I've spent the last 6 years running my own kids and 40-plus students through every major Lego robotics platform on the market, documenting exactly which ones actually build employable skills and which ones just burn money. You're listening to the STEM Lab podcast. Quick heads up before we dive in, everything you're about to hear, the research, the data, the analysis, that's all human work, verified and written by real people. But the voice reading it to you, that's AI generated. Just wanted to be upfront about that. Now, if you've been listening for a while, thank you. Really, your time matters, and I don't take it for granted that you spend some of it here. If this is your first episode, welcome aboard. We drop new episodes 3 times a week, Monday, Wednesday, and Friday, breaking down STEM learning tools, toys, and platforms with an eye toward what actually builds skills. All right. Let's jump into this Lego robotics comparison. Lego robotics kits represent the most widely deployed educational platform for transitioning children from block-based play to industry-relevant programming and mechanical engineering concepts. This analysis evaluates 8 current-generation platforms based on skill progression alignment, software compatibility, hardware expandability, and career preparation value, not entertainment factor. Let's start with the LEGO Education Spike Prime set. Check the link below to see the current price. This delivers the most complete middle school robotics curriculum in LEGO's current lineup. The 528-piece system combines Scratch-based block programming with Python text coding through the same Spike app interface, creating a genuine bridge between visual and production-level languages. Here's what matters about the hardware. You get a rechargeable hub with 6 input-output ports, Bluetooth connectivity, and about 25 hours of battery life. It runs on basically everything: Windows, Mac, Chromebooks, iPads, Android tablets, even Amazon Fire devices. Once you download the app, everything works offline, no cloud dependency for core functions. It's designed for ages 11 to 14, but the actual capability range extends way beyond that. Advanced 9-year-olds can handle basic sensor logic, while 16-year-olds preparing for AP computer science can work with multi-threaded programs and parallel process management. The curriculum materials include 45 hours of structured lessons across robotics competition preparation, invention squad challenges, and life hacks problem solving. The dual language approach positions Spike Prime as the critical transition point in a progressive STEM learning path. Students start with Scratch blocks to understand conditional logic and loops, then gradually introduce Python syntax for the same functions, seeing direct one-to-one translation between visual and text representations. You can expand it with LEGO Education expansion sets and standard LEGO Technic components. The hub uses the same connection protocol as Spike Essential and Mindstorm's Robot Inventor, so advanced users can network multiple intelligent bricks in coordinated systems. There are no consumables. Your initial investment covers hardware indefinitely. Software remains free with unlimited updates. Python is the primary language for data science, machine learning, and automation engineering, 3 of the fastest-growing technical career paths according to the Bureau of Labor Statistics' 2025 Occupational Outlook. Spike Prime's text-based coding experience directly prepares students for frameworks like NumPy, Pandas, and TensorFlow used in professional environments. Here's the friction point. The unit sensors, color, distance, force, lack the precision required for serious robotics competition at FTC or FRC levels. Teams competing in First LEGO League can deploy Spike Prime effectively. Those advancing to higher-tier competitions will need to transition to VEX or REV platforms. Now let's talk about the LEGO Mindstorm's Robot Inventor. Check the link below to see the current price. This serves as LEGO's flagship advanced robotics platform, positioned for ages 10 and up, but realistically optimized for 12 to 16-year-olds with prior coding exposure. The 949-piece set includes 5 baseline robot designs: Blast, Charlie, Tricky, Gilo, MVP, that demonstrate different mechanical principles like wheeled locomotion, bipedal walking, object manipulation, and tracked vehicles. The hardware includes a rechargeable intelligent hub with 6 ports, Bluetooth 5.0, built-in gyroscope, accelerometer, and speaker. Battery life averages about 2 hours of continuous operation. It's compatible with Windows, Mac, iOS, and Android, but you need 15 gigabytes of storage for the full software package. The programming environment uses Scratch-based block coding and Python through the Mindstorms app. Unlike Spike Prime's educational scaffolding, Robot Inventor assumes baseline competency. The tutorials are engineering-focused rather than curriculum-structured. The Python implementation exposes students to object-oriented programming concepts, including classes, methods, and inheritance. First-week achievement for most users includes autonomous navigation using distance sensors and gyroscopic stabilization. By month 3, capability typically reaches multi-sensor fusion, combining color, distance, and force data to make navigation decisions, and custom function creation. 6-month proficiency includes designing original mechanisms documented with CAD-style assembly instructions. It's backward compatible with LEGO Mindstorm's EV3 sensors and motors using third-party adapters, forward compatible with Spike Prime components. The Powered Up protocol enables integration with LEGO Technic motorized sets, dramatically extending mechanical possibilities. The hub's 32 megabytes of storage constrains complex programs, particularly those using custom sounds or large sensor arrays. Students writing programs exceeding 50 functions will encounter memory warnings, requiring optimization or modular program architecture. No subscription required. One-time purchase includes lifetime software access and unlimited firmware updates. The platform introduces gyroscopic stabilization and sensor fusion concepts fundamental to autonomous vehicle engineering, drone flight control, and industrial robotics. These same principles scale directly to ROS, Robot Operating System, environments used in professional robotics development.
Moving on to the LEGO Education WeDo 2.0 core set. Check the link below to see the current price. This occupies the elementary entry point, grades 2 through 4, approximately ages 7 to 9, in LEGO's robotics progression. This 280-piece system prioritizes mechanical understanding over programming complexity. Students build gear trains, pulley systems, and lever mechanisms while learning foundational logic structures. The Smart Hub runs on 2 AA batteries, giving you about 20 hours of operation per set. Bluetooth 4.0 connectivity. It includes 1 motor, 1 motion sensor, 1 tilt sensor. Runs on Windows, Mac, Chromebooks, iPads, Android devices, and Amazon Fire tablets. Full offline functionality after app installation. The programming framework uses an icon-based drag-and-drop interface that predates traditional block coding. It uses visual cues rather than nested conditional structures. This design choice reduces cognitive load for emerging readers, though it creates a steeper transition curve when students advance to Scratch syntax platforms. It's designed for students still developing abstract reasoning, typically 2nd through 4th grade. The curriculum assumes adult facilitation for reading comprehension and troubleshooting. Advanced kindergartners and 1st graders can manipulate the software but struggle with the engineering design challenges without scaffolding. The curriculum includes 40 hours of standards-aligned science and engineering projects organized around earth science, physical science, space exploration, and engineering design. Each project requires 2 to 3 sessions to complete investigation, documentation, and iteration. This functions as the bridge between construction play and programmable systems. Students completing WeDo's curriculum demonstrate readiness for Spike Essential or Boost as next-level platforms. You'll need periodic AA battery replacement. Calculate approximately $15 per year for moderate use, about 3 to 4 hours weekly. Here's the limitation. The single motor constraint means students cannot build differential drive systems or manipulators with simultaneous multi-axis movement. This intentional simplification prevents frustration, but also limits mechanical complexity exploration. It introduces gear ratios, mechanical advantage, and energy transfer, fundamental mechanical engineering concepts that remain constant from WeDo through professional CAD systems and industrial machinery design. Next up is the LEGO Boost Creative Toolbox. Check the link below to see the current price. This positions itself as the consumer market entry point for programmable LEGO systems, targeting ages 7 to 12 with an entertainment-forward approach. Despite the toy-adjacent marketing, the 847-piece set delivers substantive coding education through 5 buildable models: Vernie the robot, Frankie the cat, Guitar 4000, MTR4, Multi-Tooled Rover 4, and Auto Builder. The Move Hub runs on 6 AA batteries, about 15 hours runtime. Interactive motor, color and distance sensor, Bluetooth 4.1 connectivity. Here's the catch: it requires a tablet or smartphone, no desktop support. Compatible with iOS, Android, Amazon Fire 7th generation and up. Tablet screen size minimum 7 inches recommended for comfortable interface interaction. The programming environment is Scratch-inspired block coding through the LEGO Boost app, uses horizontal drag and drop rather than vertical nesting, which some younger users find more intuitive than traditional Scratch. Supports loops, conditionals, variable creation, and sensor-triggered events. It successfully introduces algorithmic thinking to 7- and 8-year-olds who find WeDo's project-based structure too abstract. The playful models provide concrete context. Students program Frankie to purr when petted using the proximity sensor, or Guitar 4000 to change tones based on color brick input. This serves as an alternative entry point to WeDo for home environments without formal curriculum requirements. Students completing Boost's 5 models demonstrate readiness for Spike Prime's competition-oriented challenges. The single motor limitation mirrors WeDo. The Move Hub's AA power creates higher ongoing consumable costs than rechargeable platforms. Estimate $25 to $30 annually for typical use patterns. The tablet-only restriction eliminates this platform from classroom environments still dependent on desktop computers. This technical decision significantly limits Boost's institutional adoption, despite otherwise solid educational design. It's compatible with standard LEGO and LEGO Technic components, but not cross-compatible with WeDo, Spike, or Mindstorm's intelligent hubs. Students outgrow the platform rather than upgrade within the same ecosystem. This represents the lowest total investment for introducing algorithmic thinking to 7- to 9-year-olds in home environments. Not recommended for formal educational settings due to software compatibility constraints and lack of curriculum alignment materials. Now, let's look at the LEGO Education Spike Essential Set. Check the link below to see the current price. This fills the gap between WeDo 2.0 and Spike Prime, targeting elementary students in grades 1 through 5, ages 6 to 10, who need more programming sophistication than WeDo offers but aren't ready for Spike Prime's competition focus. The small hub has 2 motor ports and 2 sensor ports, rechargeable lithium battery with about 8 hours runtime, Bluetooth 4.2, includes 2 small motors, color sensor, light matrix. Runs on Windows, Mac, Chromebooks, iPads, Android. fully offline after app download. The programming interface uses word block coding that represents the midpoint between WeDo's icon system and Spike Prime's scratch blocks. Each command displays both an icon and text label, transitioning students toward text-based thinking while maintaining visual scaffolding. It provides more than 50 hours of STEAM lessons organized around storytelling and problem-solving scenarios. The narrative-driven structure engages younger learners more effectively than pure engineering challenges. Projects integrate literacy, math, and social-emotional learning with technical skill development. 6-month progression typically moves from sequential commands, do A, then B, then C, through conditional logic, if X, then Y, to nested loops with multiple sensor inputs. This pacing aligns with Piaget's concrete operational stage cognitive development. The studs and bricks design uses larger components than Spike Prime or Mindstorms, optimizing for smaller hands and developing fine motor skills. First and second graders can assemble models independently. WeDo and Spike Prime often require adult assistance for this age group. It's designed as WeDo's successor. Schools deploying WeDo 2.0 in grades 1 and 2 typically transition to Spike Essential for grades 3 through 5, then Spike Prime for middle school. This creates a continuous LEGO robotics pathway from age 6 through 14. No consumable costs. The rechargeable hub eliminates battery replacement. The 2-port limitation restricts designs to single motor movement plus one sensor or dual motor drive without sensors. Students ready for multi-sensor fusion projects will outgrow the platform quickly. It includes classroom management tools, assessment rubrics, and standards alignment documentation, features absent from consumer products like Boost. This support structure justifies the price premium for institutional buyers, but provides minimal value for home learning environments. Let's talk about the LEGO Mindstorms EV3 Education Core Set. Check the link below to see the current price. This represents the previous generation flagship platform, officially discontinued in favor of Robot Inventor, but still actively deployed in thousands of classrooms and FLL competition teams. The 541-piece educational version includes rechargeable battery, color sensor, 2 touch sensors, gyroscope, and 3 motors. The EV3 intelligent brick has an ARM9 processor, 16 megabytes flash memory, 64 megabytes RAM, micro SD expansion slot, 4 motor ports, 4 sensor ports, USB host and client, Bluetooth 2.1. Rechargeable DC battery with approximately 4-hour runtime. Runs on Windows, Mac, iOS, and Android. Also supports Linux-based operating systems, including EV3 Dev for advanced users.
It ships with LEGO Mindstorms Education EV3 software, LabVIEW-based graphical programming. Also compatible with Scratch extensions, Python via EV3 DEV, Robots-C, that's a C-based language used in VEX competitions, and Java through Legos. This multi-language flexibility makes EV3 the most versatile LEGO platform for progressive programming education. Here's why it remains relevant in 2026. The platform's maturity means extensive third-party sensor ecosystem, comprehensive troubleshooting documentation, and proven competition viability. Teams with existing EV3 investments face no pressure to upgrade. FLL explicitly supports EV3 through at least the 2028 season. The micro SD slot enables custom Linux installations, transforming the brick into a standalone robotics computer running OpenCV computer vision, TensorFlow light machine learning models, or ROS nodes. This positions EV3 as a genuine bridge to professional robotics frameworks, capabilities Robot Inventor cannot match despite newer hardware. Students mastering EV3's full capability stack demonstrate competency in sensor calibration, PID control loops, state machine architecture, and real-time operating system concepts, all directly transferable to industrial automation and embedded systems engineering. Here's the drawback.
The platform's complexity creates steeper initial learning curves than Robot Inventor. First-time users without instructor support often struggle with sensor configuration and troubleshooting. Schools benefit from this depth. Home users may find Robot Inventor's streamlined experience more appropriate. The rechargeable battery pack eventually degrades. Typical lifespan is 500 to 800 charge cycles over 3 to 5 years. Replacement packs cost approximately $80. Alternative, the set operates on 6 AA batteries using the standard battery pack. As discontinued product, availability fluctuates. Used education sets from upgrading schools offer value if you confirm complete sensor inventory and functional battery. Now for something completely different, the LEGO Education Brick Motion Essential. Check the link below to see the current price. This breaks from the robotics category entirely. It contains zero electronics, sensors, or programmable components. This 523-piece set instead focuses purely on mechanical physics for grades 1 and 2, ages 6 to 8, teaching force, motion, energy transfer, and simple machines through hands-on experimentation. Including a non-programmable set in a robotics-focused guide reflects real-world learning progression. Students who understand mechanical principles through physical manipulation demonstrate significantly stronger performance when adding programming complexity. Brick Motion builds the foundational schema that makes WeDo and Spike Essential more intuitive.
No power requirements, no software, no connectivity. Pure mechanical components. Includes gears, axles, wheels, weights, pulleys, and specialized elements for physics demonstrations. The curriculum organizes 45-minute lessons around cause and effect relationships. Students manipulate variables, gear size, weight placement, incline angle, and observe outcomes, building empirical reasoning skills before introducing abstract programming logic. Completing Brick Motion curriculum correlates with stronger spatial reasoning scores and improved troubleshooting persistence when students advance to programmable platforms. The tactile feedback of watching gear trains accelerate or balanced levers tip provides concrete reference points for later abstract coding challenges. It functions as the ideal pre-WeDo experience for kindergarten and first-grade students. Schools implementing Brick Motion in K through 1, WeDo 2.0 in grades 2 and 3, and Spike Essential in grades 4 and 5 report smoother skill progression and higher middle school Spike Prime performance compared to programs introducing programming without prior mechanical foundation. It's entirely reusable with no wear components beyond typical LEGO brick longevity, which is effectively infinite for educational applications. Students seeking immediate robot building gratification will find Brick Motion frustrating. There's no autonomous movement, no programming, no blinking lights. This is exclusively a mechanical engineering teaching tool. Parents expecting screen time and coding from every STEM investment should skip this set. The National Science Teaching Association's 2024 position statement on elementary engineering education specifically calls out hands-on mechanical exploration as prerequisite for computational thinking, directly validating Brick Motion's pedagogical approach. Finally, let's look at LEGO Technic robotic kits with third-party powered-up integration. High-capability LEGO Technic sets, including Liebherr R9880 excavator, Bugatti Chiron, and Cat D11 bulldozer, can integrate powered-up motors and hubs to create sophisticated, programmable mechanical systems. This approach combines Technic's advanced building techniques, complex gear trains, suspension systems, pneumatics, with app-controlled programming. You'll need to purchase LEGO powered-up components separately: Bluetooth hub, motors, battery box. Hub, powered by 6 AAA batteries, connects via powered-up app on iOS or Android. No desktop support. The powered-up app offers basic control interface, forward and reverse speed adjustment, timed sequences, and sensor-triggered actions if you add third-party sensors. This represents significantly less programming depth than Spike or Mindstorm's platforms.
Here's why you'd consider this path. For students ages 11 and up who demonstrate stronger spatial and mechanical reasoning than computational interest, Technic builds provide extraordinarily sophisticated mechanical engineering challenges. Adding powered-up components introduces automation concepts without requiring algorithmic thinking fluency. Technic building instructions represent the most complex technical documentation in LEGO's product line, comparable to professional assembly manuals. Students completing flagship Technic sets demonstrate patience, procedural following accuracy, and mechanical troubleshooting skills that transfer directly to CAD assembly environments and technical careers. Mechanical engineering, industrial design, and technical illustration all value the spatial reasoning and documentation interpretation skills Technic builds develop. These career paths don't require programming fluency, but do demand mechanical systems understanding. Advanced students can combine Mindstorms or Spike Prime hubs with Technic structural components, creating robots with professional-grade mechanical systems controlled by educational-grade programming platforms. This hybrid approach represents the highest complexity level achievable within LEGO ecosystems. Flagship Technic sets range from approximately $300 to $450 as static builds. Adding powered-up hub and motors adds another $150 to $200. This positions motorized Technic as premium-tier investment, suitable for dedicated mechanical engineering interests. Not recommended for students seeking programming skill development. The powered-up interface teaches minimal computational thinking. Pure Technic represents mechanical education with light automation capability rather than robotics education. So how did I make these picks? These selections reflect three evaluation frameworks: technical capability assessment using systems engineering criteria, learning science validation through established pedagogical research, and marketplace demand analysis based on hiring trend data from 2024 through 2026. Each platform underwent direct testing across representative user profiles, ranging from 6-year-olds building first mechanisms to 16-year-olds implementing state machines and PID controllers. I personally ran both my children through the WeDo Spike Essential, Spike Prime progression from ages 7 through 13, documenting capability milestones and friction points. The included platforms represent those demonstrating measurable skill acquisition aligned with industry-relevant competencies.
Technical evaluation criteria included software compatibility breadth, operating system support, online and offline functionality, longevity of platform support, hardware expandability, sensor ecosystem, cross-platform compatibility, industry-standard protocol adoption, programming language progression, alignment with K-12 computer science frameworks and professional development paths, mechanical sophistication, complexity ceiling, alignment with engineering design principles, durability for repeated assembly cycles. Excluded platforms included discontinued products without active software support, proprietary systems lacking expandability, and robotics kits with pre-assembled components offering minimal engineering learning. The capability milestone descriptions derive from observational data across more than 40 students in structured learning environments, not manufacturer marketing claims. Skill timeline estimates assume 2 to 3 hours weekly engagement with appropriate adult scaffolding for elementary-aged users. Let me answer some frequently asked questions. What programming languages do LEGO robotics kits teach, and which ones matter for future careers? LEGO Robotics Kits teach icon-based programming with WeDo 2.0 and Brick Motion Essential, word block coding with Spike Essential, boost-based block programming with Spike Prime and Mindstorm's Robot Inventor, and Python text-based coding with Spike Prime and Mindstorm's platforms. Python represents the critical career-relevant language. It's the primary tool for data science, machine learning, automation engineering, and scientific computing. Scratch and block-based environments serve as scaffolding for developing algorithmic thinking but don't directly translate to professional applications. Students should progress toward Python exposure by age 11 or 12 to build genuine employable skills, rather than remaining in visual programming environments.
Which LEGO robotics kit should I start with based on my child's age and experience level? Start with Brick Motion Essential for ages 6 to 7 with no prior experience, focusing on pure mechanical foundation. WeDo 2.0 works for ages 7 to 9, emerging readers, for first programmable systems. Spike Essential fits ages 8 to 10 who are comfortable with guided projects, offering structured elementary progression. Boost suits ages 7 to 10 in home environments without curriculum needs for playful coding introduction. Spike Prime targets ages 11 to 14, ready for Python transition and middle school competition preparation. Mindstorm's Robot Inventor works for ages 12 and up who are self-directed learners tackling advanced independent projects. The correct choice depends more on current capability than chronological age. A mechanically minded 9-year-old with prior block coding exposure may thrive with Spike Prime, while an 11-year-old new to robotics should start with WeDo or Boost.
Do LEGO robotics kits require subscriptions, ongoing consumables, or additional purchases to remain functional? LEGO education platforms, WeDo, Spike Essential, Spike Prime, Mindstorm's EV3, Brick Motion require 0 subscriptions and include free lifetime software access. One-time purchase covers indefinite use. Consumer platforms like Boost and Robot Inventor similarly avoid subscription models. Consumable costs include AA or AAA battery replacement for WeDo 2.0 and Boost, approximately $15 to $30 annually depending on usage, while rechargeable platforms like Spike Prime, Spike Essential, and Mindstorms eliminate battery costs. Optional expansion sets add sensors, motors, and building components but aren't required for core functionality. The most significant hidden cost comes from outgrowing platforms. WeDo and Spike Essential hardware cannot upgrade to more advanced systems, requiring new hub purchases for progression. Budget for platform transitions every 2 to 3 years as students advance, rather than expecting single kit longevity from elementary through high school. How do LEGO robotics kits compare to VEX, Arduino, and Raspberry Pi platforms for building real engineering skills? LEGO robotics kits excel at teaching mechanical engineering principles, algorithmic thinking, and sensor integration through constrained, well-documented ecosystems, ideal for ages 6 to 14 building foundational skills. VEX platforms, IQ, V5, VEX Go, offer more precise sensors, metal construction for competition durability, and C++ programming that directly prepares for FRC competition and embedded systems careers. Better for ages 12 and up focused on competitive robotics. Arduino kits require breadboard prototyping, component-level electronics understanding, and C or C++ coding, appropriate for ages 14 and up transitioning to industry-standard microcontroller development. Raspberry Pi introduces Linux systems administration, Python scripting, and computational vision frameworks used in professional robotics, suitable for ages 15 and up with prior programming experience. LEGO platforms should be viewed as the foundation layer in a progressive path that advances toward Arduino and Raspberry Pi by high school rather than comprehensive platforms spanning elementary through career preparation. Here are my final thoughts. LEGO robotics kits serve one purpose: building the mechanical intuition, algorithmic thinking, and iterative problem-solving habits that enable students to tackle industry-standard platforms by high school. They are not complete robotics education. They are kindergarten through middle school foundation work. The correct platform depends entirely on current capability and learning environment. Schools benefit from education series curriculum integration. Home environments gain flexibility from consumer platforms. Students demonstrating sustained interest should budget for platform transitions every 24 to 30 months as they outgrow each system's capability ceiling. View these investments through 10-year progression timelines rather than individual product purchases. A 6-year-old starting with Brick Motion who advances through WeDo, Spike Prime, and Arduino by age 16 demonstrates employable embedded system skills.
That same student, remaining in boost or entry-level platforms through middle school, learns entertainment value but builds minimal career relevance. The hiring data remains clear. Python fluency, sensor integration competency, and documented portfolio of progressively complex projects create measurable advantage in technical career paths. LEGO robotics kits can develop all three, but only when deployed as deliberate stepping stones rather than standalone toys.
That wraps up this episode of the STEM Lab podcast. Thanks for listening. New episodes come out every Monday, Wednesday, and Friday, so there's always something new coming down the pipeline. If this was helpful, I'd really appreciate it if you could leave a 5-star rating and write a quick review. It sounds small, but it's genuinely how other people find the show. Podcast algorithms love that stuff, and it helps us reach parents and educators who are searching for exactly this kind of breakdown. And if you haven't already, hit subscribe or follow so you get notified the second a new episode drops. Thanks again. I'll see you in the next one.